Hi, everyone. So we're picking up where we left off yesterday with section 1.3, and this was on our introduction to functions. For this next part, you are given an equation, or we might also call this a rule, along with a specified domain to determine the range of the function. All right. So in previous sections, we may have been told that one of our variables equaled a specific number and we had to evaluate it. So this is no different, except here we're told x equals 2, x equals 6, x equals 10, and x equals 12. So we have to evaluate the rule for each of these values of the variable 2, 6, 10, and 12. So as always, we take the value of the variable and substitute it into the equation for x. So we're replacing x with 2 and then simplifying. 1/2 times 2 is 1 plus 7 gives us an output of 8. And then we substitute 6 in for x. In this case, we get an output of 10. Now substituting 10 in for x and simplifying, we get an output of 12. And lastly, substituting 12 in for x. That simplifies to 6 plus 7. And we get an output of 13. So now we've used all of the values in our domain and found corresponding outputs, and this would represent the range. So we might say that the range, using those braces we used yesterday, is 8, 10, 12, and 13. So whenever you are given a rule or an equation, sometimes you'll see a completely blank table. So I'm going to draw a vertical here so I have space. Like I said, it might be completely blank, but you can specify inputs such as 0, 1, 2, maybe 15, and then use those inputs and evaluate them into the rule to find the corresponding outputs. You'll see this when we start to make graphs and things like that. For this next part, you'll see the directions got cut off at the bottom of the page and the corresponding table is on the next page. So here it's asking us to write a rule for the function. Essentially, we are converting one representation, in this case a table, into a rule. So we want to start out with y equals. All right. Really, we are just looking for a pattern here. How are we starting with our input and getting our output? So how do we get 4 and end up with 8? How do we get 7 and end up with 11? Start with 10, end up with 14, start with 13, end up with 17. So I usually start with one of the 4 major operations: addition, subtraction, multiplication, division. Sometimes it might be only one operation. Sometimes it could be a combination of 2 or 3 operations. Well, in this case, I think we can see that it's just simply the operation of adding 4. So if we add 4 to our input, so in this case 4 plus 4 equals 8. Starting with our input of 7, 7 plus 4 equals 8. And then 10 plus 4 equals 14. So as you can see, each of these numbers represent our inputs. So these are all just x. And then each of these numbers represent our output. So we would replace them with y. And that allows us to write our rule, or what I've said in class called generalizing. So we have y equals x plus 4. One more note for this table. When you are looking for the pattern, you may have first tried multiplication because we know 4 times 2 gives us 8. However, you have to try that with each ordered pair, and if we apply that same idea to 7, 7 times 2 does not equal 11. So we know that that pattern doesn't work here, and adding 4 instead was what created this rule. Now it's your turn to try. You're going to find a rule for the table for the following function. This is similar to the border problem we talked about last week. We started with the 10 by 10 border, and then eventually we generalized to find a rule that determines the border for any n by n grid. So pause the video and try finding a rule for this table yourself before watching the answer. All right, so you might start by comparing all of the outputs to the inputs. How is 0 related to 3? Well, 3 times 0 is 0. 3 minus 3 is 0. Those might be our two options. But then we apply it to the next ordered pair. 5 times 0 would also be 0, so that doesn't work. But 5 minus 3 does equal 2. So we can write all of those out. 3 minus 3 equals 0. 7 minus 3 equals 4, and 9 minus 3 equals 6. As you can see, I kind of color-coded all of my inputs the same color in the equations and all of my outputs the same color. This really lets us see the format of our rules. So everything in blue represents y. Everything in the lighter red represents x. And then everything in the pinkish purple just tells us what operation to use that creates our rule itself. So x minus 3 equals y. And that would be the rule for this table. We could also write this as y equals x minus 3, and that would mean the exact same thing. So I just want to point out this week I will be posting the solutions to the practice problems right away. What I ask of you is that you're trying these questions out yourself before going and looking at the actual solutions, all right? A part of getting better at math is just sometimes practicing and making mistakes and then learning from those mistakes, all right? So it's not going to do you any good to just go in and copy all of the answers. If you're uploading a sheet that has all of the correct answers, I'm probably going to be curious anyway, because I expect you to make mistakes since you're just learning something new. All right. So again, I just ask that you try out the problems for each practice section, and then after you've tried them out, go and check your solutions. All right. If there's something you're still not understanding, please email me before coming to class Monday. That way we can try to figure it out. and save ourselves some time. And actually, I won't even be seeing you until Tuesday next week. All right?